Okay, so in this video we're gonna talk about solution of initial value problem using Laplace transform. Now given a function of t or y as a function of t, then the Laplace transform of the nth derivative of y is equal to the following. So the only term that is positive here is the first term, and then the remaining terms are all negative. The power of s is decreasing by 1, and then on the second term you have y of 0 followed by y prime of 0, and so on. The order of the derivative is decreasing by 1 up to n minus 1 derivative. Y of 0, y prime of 0, y double prime of 0, and so on are the initial conditions of the derivatives. Usually t here denotes the time, and at the initial condition t will always be 0. Now let's solve this initial value problem. This is a first order differential equation, non-homogeneous, so this can be solved using the method of undetermined coefficient or the method of variation. Now in this case we will solve this using Laplace transform. Okay, so first is to take the Laplace transform of each of the terms in the given equation, and now if you have a constant, you put it before the operator. So this one is y prime, so Laplace of y prime, so Laplace of y. Okay, 6 Laplace of sine 2t. Okay, now we apply the definition of derivatives here now. So for y prime, this is s Laplace of y minus y of 0. Okay, and then copy 6 times this is 2 over s squared plus 2 squared is 4. Okay, then apply now the initial condition. This is equal to 1, so we get here 2s Laplace of y minus 2 plus Laplace of y. We have 12 here, s squared plus 4. Okay, solve for Laplace of y. So factor out, you have 2s here, you have plus 1 here, and then transpose this one. Okay, so I get here plus 2, and then combine. Okay, so this is 2s squared plus 8 plus 12 is 20. Okay, so solving for Laplace of y. Okay, we can factor out 2 here. Okay, and then cross multiply here, but you can factor out 2. Okay, so I gave here 2 s plus 1 half here, and then s squared plus 4, so this will cancel out. And then if you solve for y, you get the inverse, okay, of s squared plus 10 here over s plus 1 half, okay, s squared plus 4. So we solve this by partial, okay, by partial fraction. Let's move on to the next slide. Okay, so we solve this using Okay, partial fraction. So the equivalent partial fraction of this is, okay, we put a constant for the linear factor, and then for quadratic, the numerator is bs plus c. Okay, for the quadratic factor. And then we solve for the constant. Okay, so cross multiply here, so this will give you a times s squared plus 4 plus bs plus c multiplied by, so cross multiply, so this will cancel out, so s plus 1. And then for the we equate the coefficient now of similar terms starting with s squared. So I get here 1, tapos this is a s squared, this is b s squared, so plus b. And then for the linear term, no linear term here, so the coefficient is 0, no s here. This will give you b 1/2 bs, so 1/2 b here, so this will give you cs, so plus c. And then for the constant, this is 10, you have 10 here, 4 times a, okay, that's constant, c times 1/2, so this is also constant, 1/2 c. So you have three linear equations. Okay, so we solve for the constant. Okay, so that, okay, using your calculator, okay, your a here is 41, okay, over 17. E is negative 24 over 17. C is 12 over 17. So therefore, okay, your y here is equal to the inverse of your a, which is 41 over 17 over s plus 1/2, okay, plus we can split this one to bs over s squared plus 4 and c over s squared plus 4. B is negative 24 over 17, okay, multiplied by s squared plus 4, okay, plus c is 12 over 17 over s squared plus 4. Okay, so we now get the inverse. This is exponential, okay, e to the negative 1/2 t. Your a here is negative 1/2. This is for cosine function, so negative 24 over 17 cosine 2t. This is your a squared, a is 2, and then plus you should have a here is 2, so you have a correction factor of 2, okay, so that will be 1/2. Okay, so we get 6 over 17 sine of 2t. So this will give you 12 over 17, and then you should have a correction factor because you should have 2 here. You add 2 here and then divide by multiply by 1/2. Okay, so 2 over S squared plus 4 is your sine function. 12 divided by 2 is 6. Okay, so this is your final solution. Okay, let's have another one. This time this is third order derivative. Okay, so Laplace of y triple prime minus 2 Laplace of y double prime minus Laplace of y prime plus 2 Laplace of y equals Laplace of e to the negative t. So this is s cubed. Okay, Laplace of y, okay, minus s cubed, so s squared, y of 0, minus s, y prime of 0, minus y double prime of 0. Okay, minus 2 quantity y double prime, so s squared Laplace of y minus s y of 0 minus y prime of 0 minus, okay, quantity s Laplace of y, so this is Laplace of negative y prime, no? So minus y of 0 and then plus 2 Laplace of y, so just copy, equals, you have 1 over s plus 1, where a here is negative 1. And then we now substitute the initial condition. So this is 0, this is also 0, this is equal to 1, this is equal to 0, this is also equal to 0, this is also 0. Okay, so simplifying. Okay, and then at the same time factor out Laplace of y, so I get here s cubed minus 2, this is minus 2 s squared, okay, 0, 0, minus s Laplace of y, tapos plus 2. Okay, and then you have 1 over s plus 1 here. You have this is 1, this is not equal to 0, so minus 1 transpose to the right hand side, you get plus 1. Okay, so let's simplify this. So s plus 1, so s plus 2, s, so 1 plus 1, 2, and then Laplace of y is equal to, okay, factor out s cubed minus 2 s squared, okay, minus s plus 2. Okay, you can use your calculator, so this will give you s plus 1 okay, you can check later, s plus 1, s minus 2, and then s minus 1. Okay, so s plus 1, so s minus 1, okay, s minus 2, and then this is s plus 1 quantity squared. Okay, so let's move to this next slide, no? And then you solve for y here. When you solve for y, you get the inverse of this. Yeah, that's it. Okay, now we again solve this by the method of or the method of partial fraction. So okay, this is equivalent to a over s minus 1. For the linear term, the numerator are constants, and then for a repeated, okay, so still constant, s, then another constant for the second factor. Okay, so if this is raised to the power 3, so add another constant here. The denominator is now s plus 1 to the power 3. Okay, so in the right hand side you have s plus 2 to solve for a, b, c, d, no? And then cross multiply, so I get here s times s minus 2 s plus 1 quantity squared, okay, plus b s minus 2, so s minus 1 times s plus 1 squared plus c, okay, s minus 1 s minus 2 s plus 1 plus d s minus 1 s minus 2. Okay, so check, so c over, okay, s minus 1 s minus 2 s plus 1, and then s minus 1 s minus 2, okay, and then equate each denominator to 0. So let's say s minus 1 equals 0, that gives you s equals 1. So substitute here, so I get here 3, 1 plus 2. So those terms with s minus 1 will be 0. So I get here s 1 minus 2, so negative 1. This is 2 squared, 1 plus 1. This will be 0. S minus 1, so this is 0. This is also 0. So a is 3 over, negative 3 over 4. Okay, for negative 4, okay. And then what else? S plus 1, so that's, so s equals negative 1, so this is 1, negative 1 plus 2. So those terms with s plus 1, so this becomes 0, s plus 1, so 0. Okay, s plus 1, so 0. Plus d, negative 2 here, negative 1. Negative 1 minus 2 is negative 3. So your d therefore is equal to negative 1 over 6. What else? So 2. S equals 2. So 2, we have 4 here. So those terms with s minus 2 will be 0. 2 minus 2, so 0. Okay. Here you have b, 1, 2 plus 1, so 3 squared, 0, 0. Excuse me. So your b is equal to 4 over 9. Okay, and then maybe we can, to solve for the third constant, you may assign s to be 0. So you have 2 here. This is the most convenient value, no? Your a is negative 3 over 4. So negative 2, 1. Okay, s is 0. So plus b is 4 over 9. Okay, negative 1, and then 1 plus c negative 1, negative 2, 1, 0, 0, 0, and then d is negative 1 over 6. Okay, negative 1 times negative 2, 0, 0, negative 1, negative 2. D is negative 1 over 6. So you can now solve for C. What is C? Do I have here 2? So 2, okay, minus 3 over 4. So you may solve the constant here. So I can now move to the value of y. So a here is negative 3 over 4. So negative 3 over 4. This is exponential. So e to the t. Okay. And then this is also exponential. B is 4 over 9. So 4 over 9. E to the 2t. Okay. Your a here is negative 1. So plus, okay, plus c, whatever you will get here, multiply by e to the negative t. A is negative 1. This one is translation, no? Your d is negative 1 over 6. This is 1 over s squared. The inverse is t. And then multiply by exponential. Your a here is negative 1. So e to the negative t multiplied by t. Okay, for 1 over s plus 1 quantity squared. Okay, and this is your final answer.